Jablan here. So this is another recording. Remember, I hope you watched the ANOVA video. So this is Factorial ANOVA when we have two independent variables. So in this case, so this is just fiction data. Don't think that it is true. So the dependent variable here is, these are the marks for statistics. So I want to assess if there's a significant, actually, Factorial ANOVA assess three hypotheses. So the first one is for factor A, the second one for factor B, and also how the two factors interact. So we'll be able to assess if there's a difference between online and contact mode when learning or being taught statistics, and also your age. Does your age influence? Does it have an effect on the statistic mark? So the younger and the mature, I didn't want to write old here. And as well, if the format is interacting with that age. So these are the two independent variables. So they're called factors. So this is Excel. I don't know how to pronounce it. I'll try to be as quick as possible. So Excel is quite simple in terms of how it presents the data. So I'm going to show you Excel, and SPSS. So I hope you will be able to read the rest of the stuff around assumptions, which assumptions should not be violated, especially the homogeneity of variance. And also you see that there's a test of normality of these for online contact, for the dependent variable. Are they normally kind of distributed? You can read around that. I don't want to waste much time on that, but I want to show you how. So this is for single factor, remember, and this is for two factor, because we have two independent variables. And it can be also a number of categories. It can be online, contact, or hybrid, depending, or we can even have another category here for maybe young or mature, and I don't know what else, those who don't have age, I'm just saying. And you click on OK here. I did that already, but I just want to show you, I didn't want to waste time. So you select, so you should enter your data correctly, like the way that I did, so you should have 1, 2, 3, 4, 5, kind of 1, 2, 3 columns, 1, 2, 3, so that the data is correct, so that you are able to do what I want to show you now. And then you select from here, and you drag across and down, and then you release. And then it's going to ask you how many rows. It will be blank like this. So I entered before, I wanted to be prepared so that I didn't want to waste your time. So it will ask you how many rows per each sample. And we have 1, 2, 3. They should be equal. They should be equal. Unless there's a difference, but in SPSS, you are able to do a search. And then you click on OK. So for SPSS, it's quite quick. And like what I was saying, let us move a little bit like this. But before we move, right click and round off to 2 decimal places. So format cells. I have another video similar to this one. I did it like 2 years ago. I don't know how I was saying there. I'll check on it as well. You can have a look. I'll check. It's there on my YouTube channel. So I'm not scripted, so I do apologize if I maybe say something that you may not like. So, but the table that is important is actually this ANOVA table. Okay. So what we are checking on there is actually this is for sample and column. This is for factor A. This is for factor B. This is for interactions. So we have the 3 hypotheses. You can read around it, and then what you check, you want to check if there's a significant difference between the mean scores, or if there are more than 2, at least between the 2 scores. So you can check if it's less than 0.05, like what I've just said. In psychology, mostly we use 0.05, and other social sciences. So this is greater than 0.05, means there's no significant difference. I think this one is for age, younger and older. And then the columns, that is the format of learning statistics. It doesn't matter. There's no significant difference as well between the format of online or contact. And then also the 2 are not interacting. So for interactions, you check if the lines are in parallel or if they're not in parallel. Is it parallel? Is it? That's correct. That will always give you problems. But what I like about SPSS is that you can draw and construct that easily. So this is the average. These are the mean scores. You can select them like this. Copy. I want to put them somewhere here. Paste. And then for the other one, copy and select there. You can write here even to say this is for younger, and this is for, oh, I didn't say older, is it? Not sure. I almost say older. And then this is for online, and this is for contact as well. So you're able now to draw a kind of a graph, a kind of a graph for to check if there's an interaction. So you can select this this line, and you see what comes up. You can see these are the kind of lines. So if they're not crossing each other, it means that they are parallel. There is no interaction if they are almost parallel, and if they don't cross each other, that's when there's no interaction. But if they cross each other, it means that they are just hold on. There's, I want to pause that noise. There's a little bit of noise here. So here you can see the lines are not that parallel, but actually if you can check this, the mean score for contact, regardless of you're young or mature, is the same. And then when it's online, the difference is not much. So that is why I think we are getting that the third hypothesis of interaction is not significant. So there's no significant interaction between the two tables. So that's that. You can read the rest and see how it goes. And you are able to calculate the effect size. So the formula for that is actually you should take the scores for sum of squares and divide by that sum of squares for that factor A plus sum of squares within. So with this within, in other outputs, you see it's written as error. So you can check that out. It's quite easy. So you can interpret that effect size in terms of, is it small, is it medium, or is it large? I think if it's less than 0.2, it's a small effect. If it is around 0.5, it's a medium effect. If it is greater than 0.7, that is a large effect. You can read around, but what I wanted to show you is just how to run a Factorial ANOVA in Excel. And then I'm going to show you now how to do the same in SPSS. So I just opened. So the way that we enter the data is quite different. So this is a dependent variable, should be at a continuous level, but these are kind of categories. You can even check and correct before you proceed to check if that. When I entered these, actually these were at a scale. So I changed them to nominal. And I've seen another kind of output where this one was in ordinal level. It doesn't change much. So this is what you should check. So what you do, you go to analyze. Is it you go or you click on analyze, and general linear model, univariate, and the dependent variable is this one. So you click on this, the factors, the independent variables. You can select them together or like what I've just done here. So if you do like this and click on OK, it will provide you with the output for ANOVA only. And I think in the descriptive, but it is important, the contract, let's leave it for now. And then we need the plots. You can have that plot that I just showed you in Excel as well. So you this is a learning format, and this is a separate line, and click on add. And we need the line bar like this, but you do vice versa as well. So like the age, I don't know why they do that. You have to read as well. And then we add, and then you click on OK. And then if we have more than two, categories for each kind of, let's say learning format was online, contact, and hybrid, and age with 3, we can run the post-hoc. I think, remember the same post-hoc test, they use Tukey HSD, I think, remember that. So, but we don't have that here. Even if you try, let me just, let's say we want post-hoc test for both, and then you're going to select the Tukey. But it's not going to give us anything because we don't have at least 2 categories. So I'm just explaining this so that when we have them, at least to know what to do. And then mostly at this stage, I don't want to have this estimated marginal means kind of covariate between and among the variables that are involved. So we can leave this for now. I don't want to focus on this at least for now. I just select like this. And then options, this is what is important. So we need descriptive statistics, we need estimated effect size, and we need to check on the homogeneity of variance, that is the Levin test. What else here? Nothing else. Okay, and then you click on continue. Yeah, I'm done with it. And then okay, let's see what comes up. So advantage, you can go back, and if maybe you make a mistake. So this first table is just confirming how many categories and how many variables are there and how many the size of each. So we have contact, online, young, and mature. I think it's confirming that. So these are the mean scores. These are standard deviation. Just to check, you can see the younger people performed equally with the mature people for online. And then for contact, the younger people performed badly in comparison to, it's not bad per se. I don't know up to what was the maximum score, just 15 figures. This out of 20, the mature 20. So this table just helps you to check what, okay, what this was happening, something like that. And then this Levin test, I explained it last time as well. Go and check my ANOVA tab, my ANOVA video, you'll be able to check on this as well. And this is what is very important. So this is similar to this table, these values here. We check on the learning format, age, and this is the interaction of the two. This is the within. SPSS provides this error. Yeah. So this is what you check, and this last figure are actually the eta squared. So SPSS provide the eta squared. So for learning format, the effect size is 0.299. And then for age is actually very small. And what is important before you proceed, actually, what I'm supposed to say, and even in this table, is that I forgot to say that. Did I say that? There are no significant, I did say so, because they are greater than 0.005. Okay, so you should also be able to check on that. It's the same. They are not even significant as well. So these are the most important tables. This is the estimated margin. Now you can check and read around it. And these are the plots. These plots, actually, I prefer the plots that are in Excel. They make a little bit more sense in comparison to these ones, but you can check around as well and for more understanding. But what is important is for you to check if there's a significant difference between the means for factor A, for factor B, and if the interactions were significant. Okay, so let's say this was, let's say 32. Something like this. It means maybe this one is, let's say 50. No, not like that. I want it to be a little bit more. Let's say 21. So when the two lines are kind of crossing like this, it means there's an interaction. When there's a change of on learning format, that actually is influenced or affected by the age of it. It depends on the age of a person, how we understand statistics. I'm just saying, this is just fiction stories. But I wish you the best. I hope I've managed to kind of explain so that you understand and you'll be comfortable as you run your own analysis and you understand. So the rest you have to read, but most people, they struggle with analysis. That is why I chose to kind of show you what it means. And you can copy this table, right click, copy, and do whatever that you may want. You can play around. But most, why am I focusing most on Excel? Everyone almost have it. So it's a little bit cheaper for people to actually have it. So thank you so much. Thank you.